Now that we've learned about rational functions, it's time to talk about rational inequalities. For a rational inequality, the very first thing that you need to make sure happens is you have a 0 on the right-hand side of your inequality sign. Here we do have that 0 already, so we need to try to factor this as much as possible. The numerator will factor, but it will factor into imaginary numbers. So we're just going to leave that one like it is. The denominator will factor into x minus 3x plus 5. Now what I like to do is create some test points. Those test points are whatever makes each the numerator and the denominator equal to 0. So here we have x minus 3 equals 0, which means x equals 3. Here we have x plus 5 equals 0, which means x equals negative 5. So what I want to do is put each of those on a number line. Now keep in mind, if the numerator would have factored, we would need to also find the values that make that one 0. As it is, this will always be positive. When you square something, you get a positive, and when you add 1 to it, you still get a positive. So keep in mind that this numerator will always be positive. So let's pick some test points. Let's pick negative 6, let's pick 0, and let's pick 4. You can do a couple of different things, but the main thing that I like to do is just plug them straight into this expression here and see what sign we get when we do that. So we'll take a negative 6, put it in here and square it. That'll be 36 plus 1, so 37. Here we have negative 6 minus 3, that's negative 9. So far we have 37 over negative 9 times negative 6 plus 5 will be negative 1. So we get 37 over a positive 9 is greater than 0. Well, this is a positive number, right? That's what we're looking for, actually. We just want to know what sign we get. Now let's plug in this 0 and see what happens. Then we'll plug in the 4 and see what happens. So these are the signs that we get when we plug in those test points. We have a positive, a negative, and a positive. Now according to our problem, we want the parts that make the equation or the expression positive. Greater than 0 means we want it to be positive. That means we want this section and this section. Now can I use these endpoints here? I cannot, because there's no equal to sign here. It can't actually equal 0. And these are in the denominator, so you can definitely not use those endpoints. So the solution set will be negative infinity to negative 5 and 3 to infinity. I do want to show you the graph of this expression or this inequality. It looks something like this. You can see that from 3 to infinity, the function is on the upper side of the x-axis, which means y is positive. Same thing is true if you look at negative 5 and lower. The function is above the x-axis, which means that part is positive. Well, that just so happens to be the parts that we were looking for. So if this had said less than 0, we would be looking at this part of the graph. Okay, how about this one? The first thing you need to do is make sure it's got 0 on the right hand side, and it does not. So we need to subtract that 3. Now whenever you subtract fractions, you need common denominators. So your common denominator would be x plus 2. This first fraction you still have an x, but 3 you'll need an x plus 2. this is x minus 3x minus 6 all over x plus 2. So negative 2x minus 6 all over x plus 2 is less than 0. Go ahead and factor the numerator just in case something nice happens. We can factor out a negative 2 and we'll be left with x plus 3. Okay, nothing will reduce, so we go straight to our test points. Find where each the numerator and the denominator are equal to 0. So x plus 3 equals 0 means x equals negative 3. X plus 2 equals 0 means x equals negative 2. These will be our test point, or our endpoints rather. And the function can't actually have negative 3 as a 0 or negative 2 as a 0 because it's strictly less than, and also because 2 would make the denominator 0. So my test points, let's see, negative 4, between negative 2 and negative 3, let's do negative 2.5, and then above negative 2, let's try 0. So what we want to do is fill in these positives and negatives. So plug negative 4 into the function and see what kind of sign you get. So after plugging those numbers in, we get these signs. We have a negative, a positive, and a negative. Our function says we want the parts that are less than 0. That means we want the parts that are negative. Well, where are they negative? That would be here and here. So the solution set to this one will be negative infinity to negative 3 and negative 2 to infinity. So let's solve this rational inequality. We need to get 0 on the right hand side, so let's subtract. We already have common denominators, so we can just put those together. 5 minus 3x over x plus 4 is greater than or equal to 0. Now we need to determine where each the numerator and the denominator are equal to 0. So let's subtract 3x. We'll get 5 equals 3x. Divide by 3. So x is equal to 5/3. X plus 4 equals 0, so x equals negative 4. So these will be our endpoints. Can x be negative 4? Well, we do have an equal to sign, however, that would make the denominator 0. So it cannot be negative 4. Can it be 5/3? 5/3 is what makes the numerator 0. Having a 0 in the numerator is okay, as long as we have this equal to sign, and we do. So it can be equal to this number, but it cannot be equal to this number. So now we pick some test points. Let's try a negative 5, a 0, and 5/3 is the same as 1 and 2/3. So let's try something like a 3. So what we're going to do is take these test points, plug them into this function, and find out if we get a positive or a negative. After plugging in those numbers, we get a negative, a positive, and a negative. Look back at your problem to find out what it is we actually want. This says greater than or equal to 0. So that means we want the solutions to make this expression positive or 0. Now, just to be clear, we should actually look at it in this step, not this step, because we want it after we've already got everything on the same side and 0 on the right in simplified form. Okay, so we want positive or 0. That's going to be this section. That means we do not include the negative 4, but we do include the 5/3. this will be your solution set. Okay, so how about this one? Go ahead and subtract the fraction that's on the right and move it to the left. Your common denominator will be x minus 3, x plus 2. For this one, we're going to need the x plus 2. And for this one, we'll have 1 times x minus 3. Distribute x plus 2 minus x plus 3 all over x minus 3, x plus 2. So x minus x is 0, 2 plus 3 is 5. Okay, your test points will be 3, not your test points, but your endpoints will be 3 and negative 2. Can x actually equal those two numbers? No, because they're in the denominator, first of all. Second of all, because there's no equal to sign here. Pick your test points. Let's try a negative 3, a 0, and a 5. Plug the negative 3, 0, and 5 into this part of the function. See what sign you get. So after plugging in these values, we get a positive, a negative, and a positive. Our function tells us that we want the parts that are greater than 0. That means we want the parts that are positive. That will be here and here. So the solution set will be negative infinity to negative 2, 3 to infinity.